Okay, this is a question from HCV question number 16, optics chapter. You can go through the question. Question is very simple. Here we have a log of wood, which is of thickness x. This x is very small, and this wood is floating in water, and the depth of the water surface from the bed of the river or lake, whatever it is, this is a calm thing, and the depth is 2.5 meter. Now what is happening is the sun is shining, and so the rays are coming, and from the sun we know that rays will be coming parallel at some angle theta. Now if the sun is directly overhead, like in the noon time, 12 o'clock, then the rays will be coming normally like this, and at the time of setting the rays will be coming in a very slant manner, almost like at 90 degree, because the sun is going to set. So sun will be somewhere here, and from here the rays will be coming like almost like grazing way. Grazing way means like almost parallel to the water surface, or with the normal at an angle of almost close to 90 degree, like 80.9.6 or 89.8 degree, like that. So let us say that right now the sun has not yet set, and the angle of incidence is let's say here theta. Now this log of wood is here. I have drawn it actually very small for the purpose of understanding. So this is the log of wood, front face. Okay, now the rays are coming like this. So these all are the rays which are shown. Now all of these rays are falling on the water surface except for these pink colored. So these all white colored incident rays, you can see that 1 2 3 4 and then 5 6 and 7, these all are falling into the water surface, and so they will be getting refracted. Why? Because the water is transparent. However, if you see these pink rays, these are just drawn with a different color for the representation purpose. So let's call this as ray A and ray B. So the thing is, this ray A and ray B are actually falling onto the wood, and so the wood will be absorbing those rays because it is an opaque object, and it will not be transmitted. So this is not transmitted, and since this is not transmitted, so this area will be the shadow, because it will be dark, because no rays are present, whereas to the left of it and to the right of it the rays are able to pass, so it is an illuminated region. So where is the shadow forming? So that shadow forming, for that it is very simple thing. Actually what we need to consider is a triangle. So what triangle? I will tell you. So this triangle here sorry, so this length is like 2.5, and this is the angle of refraction r. So this let's say the shadow is formed at a distance of let's say z, and so we can say that from trigonometry tan of r is equal to perpendicular by base. So where the shadow is being formed is z is equal to 2.5 tan r. So for different values of r, the shadow is formed at different points. Now which value of r we should consider? In the question it is asked that the time is like setting of the sun, and setting of the sun means the angle of incidence is like close to 90 degree approximately. If the angle of incidence is close to 90 degree, then the angle of refraction is equal to almost like critical angle only, isn't it? And so this r is actually the critical angle, and critical angle tan of critical angle. Now tan of critical angle, tan theta can be written in terms of sin theta as sin theta by root over 1 minus sin square theta. And here we are talking about the grazing incidence, which means angle of incidence is almost close to 90 degree, because of which angle of refraction is equal to the critical angle, and we know that sine of critical angle is equal to 1 by mu. Here mu is that of the water, so you can write it as 1 by mu of w, and here root over 1 minus 1 by mu w whole square. And so from here you will get this value of z if you substitute the value of mu w and do the calculations.